Hi, this is Tao Luo. Today I'm going to walk you through homework 5, building a large language model, and we call it Chat NanoGPT. The GitHub repository is listed at the bottom right corner, and they will be also in the video description. The main goal of this homework is to build our own large language model, which contains pre-training and fine-tuning steps. For fine-tuning, we work on summarization and question answering tasks. The first step is data preprocessing. First, we build the vocabulary dictionaries and encode open web text datasets using builddic.py file, which will yield two dictionaries, the string-to-index dictionary and the index-to-string dictionary. Plus, it will also encode the text files on open web text dataset into indices and save as a MPY file for later use. Next is to encode the fine-tuned data, which is derived from CNN, Daily Mail, and Squad dataset using script encode fine-tune.py with dictionary built in the pre-training step. And here are two dictionaries used for this homework, and they also exist in the GitHub repository. And here's information for our pre-training model. We have tried a total of 2 architectures, and each architecture we tried 2 models with different number of parameters. Both architectures have attention-based encoder and decoder modules with cross-attention modules. The differences between architecture 1 and architecture 2 is that the architecture 1 used transformer encoder in its encoder, and architecture 2 only use multi-head attention unit in the encoder. Here are the 4 Python files used to pre-train the 4 models. They should be accessible in the GitHub repository. After pre-training, we then use CNN, Daily Mail, and Squad datasets for fine-tuning. The model checkpoints after fine-tuning could be downloaded via this link. And we also created an API like Chat NanoGPT class for easy accessing the model. Chat NanoGPT could take input of Python dictionaries or JSON format, following the syntax as shown here. It has to have a mode key to let the model know which task should it perform, and the modes are limited to summarization and question answering. Then you could put either article attribute for summarization task, or you could put context and question attribute for question answering task. Plus, this class is made to be easy for use, which you could just import the Chat NanoGPT module and place in your input. Here are the results for cross-entropy loss after pre-training and fine-tuning. As you can see in the table, Model 1 performs best in the pre-training stage, where Model 1 is the largest model we had run in this homework. Due to the limitation of computational resource, we just picked the best model at pre-training to perform the fine-tune, which then resulted for cross-entropy loss of 0.22 after 2 epochs of fine-tuning. Here's a simple demo for how you can use the model for summarization task, and it can also show you how to calculate the blue score. And this slide is a simple demo for how you can use this model for question answering task and calculating the ROC score. And if you would like to have more details of the demo, you could always go to the GitHub repository to see it. That's all. Thank you. Bye bye.